All right, good morning, good evening, good afternoon, everybody. So my name is Quentin Van Diemen, and welcome to reInvent 2020, and our discussion today about AWS's perspective on Zero Trust. So let's dive right in, because we're going to use every minute and every second of this 30 minutes we've got here together. So I'd like to start, this is essentially the fundamental question that customers have been asking since the earliest days of the cloud, right? What are the optimal patterns to ensure the right levels of security for my systems and data? And increasingly our customers are asking us how the concepts and patterns and architectures of Zero Trust apply to answering this question. So today we're going to share our perspective. We'll start with a simple definition and some guiding principles. We'll then explore into how AWS has woven some of these principles into the fabric of AWS. We'll then look towards how AWS can help you solve your own Zero Trust journey. And then we'll end with a quick demo and a view of perhaps what's next. So let's dive in. So let's start with a straightforward definition. Again, I'll let you read it, but I'd really emphasize the word security model here, right? And the real thing that I want you to take away from this is that this is a security model where we're looking to augment or replace the network-centric security models that we've been very familiar and have used very successfully up to this point. And we're going to augment those with what we can broadly classify as identity-centric controls or identity-centric models. Optimally, we want them to work better together to be able to produce security outcomes that are better than we were ever able to achieve before, right? Now, better should be understood broadly to include attributes such as usability and flexibility in addition to the security parts that are obvious. So now, from that initial definition, let's zoom in a bit, right? And there are two key dimensions that are obviously applicable in Zero Trust conversations. The first dimension that we want to zoom in on is the network, right? Do we achieve Zero Trust by allowing all network packets to kind of flow between hosts and endpoints and implement security controls above the network layer? Do we go the exact opposite direction and break down our systems into smaller logical components and implement much tighter network segments or packet level controls, what is often described as microsegments or microperimeters? Do we add some sort of gateway or proxy type technology that enforces a new type of trust boundary? Do we do combinations of the above, right? And then similarly on the identity side, right? If identity is our second dimension to zoom in on. Are we talking about human actors with PCs and tablets and phones accessing, web applications? Or are we talking about machine-to-machine, software-to-software type scenarios with much different types of identities where authentication methods and authorization techniques are far different? Or again, perhaps we're even talking about a combination of both, right? Where certain security relevant properties or attributes of an end user situation, their strength of their authentication, their device type, their device health, their ownership, their network location, et cetera, all propagate through a system in the back end to make dynamic authorization decisions, right? And what comes out of that is what comes out of that inspection process as we look at those multiple dimensions is we see arguably the potential for confusion, right? Because there's a lot of topics that are implicated, and they're often implicated in combination, and they're often implicated with a lot of buzz and hype surrounding them. However, at the same time, there's opportunities, real opportunities, to build better, more flexible, and more secure software systems. And that's what we're going to really focus in on today, are those opportunities. So if that was a simple definition and perhaps an exploration of why a simple definition can oftentimes still need further elaboration, let's now dive into some what AWS thinks are some great guiding principles for Zero Trust. So our first principle is to avoid this binary choice that's so frequently cited, right? The perimeter is dead. On one hand, you've got an identity-centric perimeter, right? Extremely granular. Maybe you might even authenticate and authorize each and every request. But on the other hand, you've got network-centric perimeters, right? These are familiar. They're easy to reason about. They filter out unnecessary noise of the system. And we would offer for you that the best security doesn't come from a choice between identity-centric or network-centric controls or perimeters. The best security comes from making this an and, not an or, wherever possible, right? The network perimeters provide guardrails within which the identity-centric controls can operate. And optimally, these two not only coexist, but they are aware and augment one another, right? A great example of this in AWS are things like VPC endpoints, right? These are network controls at the edge of a VPC where you can enforce both network-based and identity-based policies in a way that controls the flow of information across that border, right? And we'll see that more as we get into things. So our second guiding principle, and maybe to me the most important one, is to focus on use cases, right? Zero trust can mean a lot of different things in a lot of different contexts, which is arguably one of the reasons why there's so much ambiguity and confusion out there in these spaces, right? What's interesting is that these use cases, and we'll get into these three use cases throughout the talk today, these use cases all share that same fundamental technical principle, right? That we should diminish the security relevance of the network location or network boundaries. Yet they differ substantially in what they're trying to achieve for the organization. Goals might range from end user mobility, right? Mobile phones don't traditionally work super well with VPNs, but we want our modern workforce to be flexible and adaptable to be able to work from anywhere. To be at the other end, we might be talking about eliminating unnecessary lateral mobility through our network, right? In the guise of data protection and preventing a small intrusion into the network from becoming front page news, right? So again, very common technical principles. We don't trust the network. Very different organizational objectives. But when we work backwards from the problems we're trying to solve, to me, it's the absolute key to having a productive zero trust conversation. When we focus on the problems we're trying to solve and we work backwards, we are able to make meaningful progress against measurable security outcomes, and we avoid getting mired in these low-value discussions of, is this zero trust? Is this zero trust enough? To what degree is that zero trust? Like that just ultimately, it's interesting academic debate, but it's not making meaningful security outcomes. So let's work backwards from use cases. And our third principle, right, is that simply one size doesn't fit all. And I think this is true in a lot of places in the cloud, but it's certainly true when we're talking about security models as they apply to cloud workloads, right? And so over time, I think we're going to see the application of zero trust technology and these models and the associated mechanism are really going to improve defense in depth, are going to make the security controls we've got work better and better together through increased visibility and the software-defined nature of the cloud, right? So do absolutely use the tenets and these architectures of zero trust to measurably move and raise the security bar, but don't issue blanket or inflexible standards, right? Many business systems, particularly COT software and other things, network and network perimeters may, whether we like it or not, continue to be important and arguably adequate controls for a long time, perhaps ever. And so we'd really strongly encourage you to think of zero trust as additive concepts to existing controls and measures rather than wholesale replacements. Okay, so now let's get in and let's look at some examples of zero trust within AWS. And this is the zero trust that you inherit just by using the platform, right? So the most prominent example is simply how millions of customers such as yourselves securely call AWS each and every day over a diverse set of public and private networks. There's absolutely nothing about the security of AWS's API infrastructure that relies on the underlying network, right? The security here comes from the strength of TLS, augmented by AWS's signature v4 signing protocol, right? And whether it's apparent to you or not, each and every time you send an API call to AWS, that request is uniquely signed by keys, right? And on the receiving end, we're authenticating and authorizing each and every request at eye-popping rates of millions upon millions of requests per second, right? And what's been interesting to us as we have observed kind of the zero trust conversation is that cloud-based APIs are rarely, if ever, mentioned within zero trust discussions. And maybe this is because AWS led the way with this approach, this request signing approach to securing cloud-based APIs from the start, such that now it's just assumed to be a basic part of every cloud security story. So our next example is perhaps not as well understood, but is when two AWS services need to autonomously interact with one another on your behalf, they're using the same exact mechanism that you use as a customer, right? So let's walk through an example. Here, you've got in your own AWS account, you've perhaps configured an auto-scaling group, and that auto-scaling group gets an alarm that senses that it needs extra capacity, right? That alarm goes over and triggers an event in the AWS auto-scaling account, right? And in that account, we've got an IAM role, autoscaling.amazon.aws.com, what's known as a service principal. And that role is going to do the same assume role operation that you probably use fairly regularly, and it's going to assume into what's known as the service linked role in your account. That's going to result in a set of short-term AWS credentials. And the auto-scaling service is going to use those short-term credentials to do the same signature v4 signing process up to the EC2 API endpoint, right? When the EC2 endpoint receives that, it's going to turn to AWS IAM to essentially verify the signature for authentication and then authorize that request based on the policy attached to the service-linked role. And then only after all of that transpires will EC2 put the new instance in your account. Right? And what's essentially what's going on there is that even though auto-scaling and EC2 are both AWS services, they have no inherent trust, network or otherwise, of each other, and they use strong identity-centric controls as the basis of the security model as they operate on your behalf. And this is the exact same identity mechanism that you use as a customer. So the third example that we are going to look into is about adherence to AWS's security standards, right? And a great example of this can be found in our IoT service, right? When we launched AWS IoT, our adherence to our own security standards meant that we required TLS network encryption and modern client authentication in the form of certificate-based mutual TLS for connecting when connecting IoT devices to our service endpoints, right? And then in the case where you need to connect to services, broader AWS services outside the IoT family, we included mechanisms to do trusted credential exchange. So you could exchange your certificate for the sorts of AWS short-term credentials that are necessary to do the signature v4 process that we've been talking about, right? And the net effect is that every time you connect to one of these endpoints, you're using encryption, you're using modern authentication, despite the prevailing norms of the time, right? And then we subsequently added TLS support to FreeRTOS, right? And this brought essentially as a great zero trust foundation to an entire class of small CPU and memory devices that were previously assumed not to be capable of it. And so in summary, the adherence to these AWS security standards brought zero trust foundations to a domain where vast amounts of unauthenticated, unencrypted messaging was previously the norm. So now let's look at how AWS can help you on your own zero trust journey. And we're going to use 3 specific use cases as our backdrop. The first use case that we're going to look at is how we go about authorizing specific flows between components, right? Machine to machine, service to service. And again, the goal here is usually about eliminating unneeded lateral mobility through the network, right? We want to do that for the fairly obvious reason of reducing surface area of systems, especially ones that are able to eliminate unnecessary pathways to data. And the consideration here, at least as we sit today, is that sometimes these patterns follow architectures. And what I mean by that is the way you solve this for traditional virtual machines might be different from containers, might be different from APIs. There's still a little fragmentation here, but I think there's some great examples of how we do this across all of those flavors of compute. So let's look here at a simple scenario, right? We've got our employee application, right? And this discussion about unneeded lateral mobility through the network, it has to start with security groups, right? And I can almost see some of you all rolling your eyes through the other end of the virtual camera here, particularly if you've been in AWS for a while. But security groups, whether they're new to you or you haven't thought about them in this way for a while, are a really awesome, highly dynamic, software-defined micro-perimeter that does great job of constraining both north-south and east-west traffic, right? But beyond that, they have some really interesting properties. They have this notion of group membership, right? The flows between components aren't specified by saying this thing. They're specified by saying this group is allowed to talk to this other group. So as infrastructure comes and goes for sake of auto-scaling or other things, the rules that define these network flows automatically adjust around the various components. And as we put down kind of per application, per component security groups, we're able to just easily say how information should flow through an application. And then obviously if we have, it's implicit deny, right? So if we haven't specified a flow to be allowed across applications or within an application, we'll naturally be denied. Now, if that's kind of the first version of microperimeters, I think the other great primitive to bring in here are services like private link, right? And so imagine now my application needs to connect to some other services that I've built within my environment. But here I've built them in totally independent AWS accounts, in totally different VPCs with no routing and no connectivity between the two. I can use services like Private Link, and we'll see this in the demo, to drop an ENI into my local VPC, and that's going to build this narrow one-way gateway through this fabric of AWS to essentially be able to connect a service on the remote end and make it appear locally. Right? It's really, again, all of that is programmable. It's very dynamic layer 4 networking. And then on top of that, I might do layer 7 identity techniques like mutual TLS, like OAuth 2, maybe even a combination. Right? Now, I can do that for services that I've built. I can also do that for third-party services, be it monitoring services, database services. This is a really flexible way for essentially extending and connecting in things from very far-off disparate networks without worrying about routing and connectivity. And the kind of the so what of that is that, when things don't need to talk to one another, there's not a path to secure because there's not a path at all. And I think that's a really powerful thing to bring to bear as we're building these architectures. So now let's take another kind of similar example. Let's say our employee application or our employee directory application is modernized a bit, and we've traded out our relational database for Amazon DynamoDB. So there, AWS service, right? We're going to provision an IAM role underneath of our compute. That IAM role is going to automatically deliver and rotate credentials that give those machines an identity. And I can now use that SigV4 process that we've been talking about so often to connect to Amazon DynamoDB, right? So wouldn't it be great to use that same AWS authentication authorization for my own services? Well, you can, right? So I guess if we then maybe have a fleet of microservices that instead of being constructed with containers, we use a service like Amazon API Gateway. What we can do is we can use that same private link mechanism, right? Here it's just a VPC endpoint. We can attach policies, right, onto remote APIs and remote accounts that specify which callers coming from which accounts, which networks are allowed to call these various services. And then here, kind of the difference between the previous example is now AWS is actually doing both your layer 4 private networking, right, this dynamic one-way gateway through the fabric of AWS. But we're also doing the layer 7 bits as well, right? We're authenticating each and every request to your API on your behalf. We're doing all the secrets management on the caller side, right? And basically, you're left to just build the business logic of your application, which is really amazing. Again, there's no path to secure where things shouldn't talk to each other at all, and all of this fits within the broader topology of microsegmentation with security groups, right? So this architecture kind of really brings it all together in this pattern that I think is just frankly awesome 5-star cloud security that makes these conversations of simple east-west restrictions seem dated and rooted in constraints of the past. Okay, so our second use case is all about friction-free access to internal apps. And this one is very prominent in zero trust circles, right? We're trying to get a human user access to generally an internal application from anywhere, right? Again, our goal is about mobility. Our goal is about making it so that that employee can work anywhere. Now, we want to do so, but we also don't want to compromise security. We arguably want to improve security as we're going about this. And before we dive into architectures, I'll really cement to you that this is just not a one-size-fits-all scenario. We're going to look at two architectures here today, but you've got to choose the architecture here that makes sense for your workforce, whether they have corporate devices or not, your developer fluency, your regulatory domain. I think this is just clearly not a one-size-fits-all scenario. So the first way that AWS might help you solve this is with a service like Workspaces, right? We've got that internal application and the same employee directory app. It's running in a private subnet. I'm going to spin up a virtual desktop in AWS, and I'm going to take that remote user that's working from home, and I'm going to allow them to connect. They're going to authenticate through an authentication and session gateway. We're going to use directory services to go back to the corporate directory, AD or otherwise, and strongly authenticate the user. And then after I do so, we're going to use technologies like PCO over IP, right, to essentially push pixels to the user. And the so what here is, and I realize that the arrows don't perfectly reflect the diagram, right? The pixels is the top part, not the directory services part. Yes, I do understand that. But the real takeaway here is that all of your applications and data stay within AWS. What really goes out to the user is a perfectly useful, perfectly interactive form of that, but it's just pixels, right? The data never leaves the secure enclave. So now there's other ways to solve this, though. Again, depending on a lot of the nuances of your environment, but this is certainly maybe one of the most prevalent zero trust use cases there is, right? And so here we really do want to stick our trusty employee directory application straight on the internet. So we're going to take kind of a trifecta approach. We're going to take services like AWS Shield, AWS WAF, and Application Load Balancer with OpenID Connect authentication enabled, right? And as we do so, that allows us, those edge services give us protection from the kind of the craziness of the internet. We flow through that application load balancer, which you already needed as part of your app, detects that I haven't been yet authenticated. It's going to redirect the user to the OIDC compliant identity provider of your choice that's going to do all that strong and adaptive authentication, device posture, geolocation, all those sorts of things, right? And the takeaway here, again, is that from your user's perspective, you've with this architecture, made your internal applications just as flexible as your SaaS applications, right? It's a SaaS-like experience. For you, the security team, right? You've got managed protections, right? Shield, WAF, ALB. These are things that you don't have to patch. You don't have to operate. AWS has encoded the security into these services, right? And then as the application on the back end, right? You get two things. One is you get assurance that the only traffic that's getting through that front door has been strongly authenticated. But B, you get an upgrade to modern authentication, literally with almost no changes at all. And we'll see that in the demo. So our last use case, right, is about digital transformation. This is one where I think the great example is the IoT-enabled wind turbine out in the middle of nowhere using a small microcontroller to beam data and instrumentation to the cloud over arguably the world's most untrustworthy network, the internet. And this is one where the security model here, obviously, it comes into zero trust conversations because that exists wholly outside the network perimeter as it's ever existed, right? And so we clearly need a new model. Whether that's applicable to your business or not today, I'd offer to you that it's important to get ahead of it because we continue to see how essential those sorts of workloads are to business and product innovation going forward. So for sake of time, we're not going to dive super deep into this one because it's largely mirrors the AWS IoT security architectures and patterns. So please go check that out if that's of interest. So now let's flip over and let's do a bit of a demo, right? We got to do this very time compressed. So we're going to just, instead of flipping around a bunch of browsers, I'm going to embed everything in one demo, but let's give it a whirl. Let's see how this goes. Okay, so the first thing I'm going to do here is I'm going to log into my test application, right? You can see here that I've used Okta as my identity provider, and it's going to do a strong WebAuthn-based authentication, for me as I flow into the app, right? So now there was a lot that just happened there, right? So like I said, putting an application directly on the internet obviously means dealing with some of the internet's kind of dirty laundry. And those edge protection services like Shield and WAF are going to transparently take care of much of that heavy lifting for you, right? Without you doing much of a thing. But then we flow through to the ALB and we can see that it's configured for a single straightforward rule. If the user hasn't been authenticated, let's do so using OpenID Connect. In this case, my identity provider was Okta, right? But any OIDC compliant IDP works perfectly well here, right? So now this is a snapshot into the Okta console. You can see here that I forced a couple of rules in the sign-in policy, one about WebAuthn, one on geolocation. You might obviously commonly put device health and posture, behavior analysis, etc. there. And then finally into the code, right? When your auth flow returns from that IDP, ALB simply hands down a set of headers with the identity claims and access token. And you can use standard libraries to verify the signatures and then use those for personalization or downstream API authorization, right? Which we're going to see. So again, you're upgrading to modern top-of-the-line auth in just a few lines of code. Great added benefit. Okay, so now let's look at Zero Trust kind of within the application and between adjacent applications in the same subnet. So remember here, the goal is a bit different. It's about eliminating unnecessary pathways, especially those that lead to data. So to do so, we're first going to configure per application, per component security groups. And we're going to use references from one security group to another to allow very specific narrow traffic flows. So using these references means that security groups automatically flex as instances come and go. And it means that we can describe what we want in very straightforward ways. Only the ALB should be able to talk to the web servers, etc. And it avoids all sorts of static lists, right? So I realize this is an extremely simple example for many of you, particularly those who have been using AWS for a while. But we get what we expect. The web server code, can connect to my own database, but not to the adjacent database of the help desk application, even though we're in the same subnet. And so if you don't have a ton of experience, you might be thinking that dealing with all these IDs sounds just as bad. But when you see security groups as part of an overall infrastructure as code package, you start to see the references are natural and they auto-build on your behalf, right? And then finally, while not part of Zero Trust specifically, services like Session Manager can really eliminate unnecessary management pathways, right? So now let's get a little bit more fancy. Let's see about how we might leverage services that exist within, again, those disconnected VPCs through Private Link. So in my destination account, here I'm using a container service. I'm going to create a VPC endpoint service and specify the NLB front end and a private DNS name. I then allow the connection request from specific AWS accounts that I expect and authorize to connect to the service. In the source account, I create a matching VPC endpoint. And then ultimately, I complete the handshake. So now, when I look into the code, it looks amazingly and completely vanilla, which is the point. I'm simply making a standard HTTP post to a private DNS name I defined above. And even though there's literally no route from my VPC to that remote VPC, things just look normal in the code, right? Private Link works within the same chain set of security groups and then uses the fabric of AWS to kind of just get the bits where they need to go. For layer 7 identity controls, you can see that I'm passing that access token that came from Okta as a bearer token, but I could equally use mutual TLS or even a combination, right? And so this is the simple result, or this is the result of that simple API call. I authorized the user, and then I just echoed back their input. It's so simple, and it just works to the point it's almost easy to forget exactly how scoped the flows are between the security groups and Private Link. Now, I think there's more to do here, particularly around orchestration. But when you see these programmable primitives, there's really a lot to be excited about. So now this last flow, let's go through and let's see. Here again, we're upgrading our remote services to fully serverless with API Gateway. So our first step is to create a private API that uses AWS IAM authorization. IAM authorization means that callers are going to SigV4 sign their calls to your API, just like they sign API calls to AWS APIs. So next, we specify a policy on who can call that API. You'll note here that it subscribes to that and not or principle we talked about. So I'm specifying both who can call the API and where they can call it from. In step 3, back in the source account, I create a VPC endpoint and I attach a similar policy to it, right? And this policy gives a point of control to the network owner, which may be different from the API owner. Lastly, I give the IAM role that exists under the compute instance of my application permissions to call the remote API. But again, only if that flow flows through the expected network egress point, right? And if any of those policies are denied, the call won't be allowed. Again, now into the code, right? Normally, AWS SDKs do all that SigV4 work on your behalf, but you get a bit more of a taste for it here, right? The good news is standard libraries really help. And ultimately the result. So for demonstration purposes, again, I just kind of had the API print out some of the more interesting behind the scenes bit. But what you can see here is that I'm now able to authorize both the service-to-service caller and the human who's being operated on behalf of. In addition to all that layer 4 magic that we saw in the last example, now AWS is taking care of all the creation, distribution, and rotation of credentials on the caller side, and all of the request-by-request authentication authorization on the receiving side, right? All while enforcing a tight set of policy-driven identity and network control. So I realize I'm biased, but again, I think this is really pretty 5-star awesome sauce in terms of a security model, and one that I think is only really possible in the cloud, either for sake of the granularity or simply the practicality of implementing it at scale. Cool. All right. So let's finish up here, right? I know this is a lot. It's a very rapid fire. It's very condensed in 30 minutes. But I think the way I want to leave this with you today is that this is very much still day one, right? I hope that we've effectively communicated our vision for what we think Zero Trust is and how we think you ought to be thinking about it. Perhaps some of the underlying security principles. And that ultimately, this is just a fundamentally better security model that you're able to build, and you're able to build for real on AWS today. So this is still very, very much a journey. At Amazon, we love to say that it's always day one. We've got lots left to build, lots of guidance to offer, and you can look forward to seeing lots more from us in this space. Thanks for your time and attention. Have a great day.